When you start teaching physics, you will find you need a problem-solving methodology to teach the students. Now, most of physics is word problems, and students hate doing word problems. They hate doing them for the most part because they really do not know what they're being asked to do. And they really do not know where to start on problems, and you're going to help them with that. They also hate showing steps, and they hate showing steps because many of them can do the initial problems in their heads. But we're trying to teach a problem-solving strategy. We're trying to teach them how to think through problems and be very orderly in the process. I teach a method called guess. First day, I tell the students they're going to guess their answers, and they're mostly unhappy. They think they're going to be making things up. But it is very, very orderly. Guess stands for givens, unknowns, equations, solve, solutions. So when I want my students to guess their answers, I want them to write down the givens, write down the unknowns, write down the equations, then solve it, and finally give me a solution. The answer is not the most important thing in my class. For givens, there are two types: the numbers that are stated in the problems and hidden givens. Students will struggle a bit with the stated givens, mostly just trying to figure out what variable goes with which number. The hidden givens will give them a bit more problems. Hidden givens are just that. They're any number that's not in the problem as stated, and it's something they should know from context. For example, gravity is always negative 9.8 meters per second squared. It is also anything they should know from prior knowledge, from a previous unit. Now, when we start a problem, I know this is simplistic, but I have them read the problem, and I usually have them read it out loud the first time. I have them circle any number they see in the problem, and then I have them write it down. We actually spend quite a bit of time on this. This is a problem we're going to work through using guess, and it is a very challenging problem for the A1 students. You may choose to not do projectiles at an angle with them, but let's step through it. A cannon fires a shell with a muzzle speed of 600 meters per second at 30 degrees. Find the time to the range. We read it aloud, and I do actually point at each word as we read it the first time. I circle the numbers in the problem, and then I write everything down. All right. Same problem, and I write the word given, G-I-V-E-N-S, and the first thing they're going to write down is every number they actually see in the problem. The initial velocity is 600 meters per second, and the angle theta is 30 degrees. But we're missing the hidden givens. They should know that the acceleration in the y direction is negative 9.8 meters per second squared. And at the range, I know the change in the y displacement is 0. So here I have my stated givens and my hidden givens. Unknown. Tragically, a lot of students will try to solve problems without knowing what they're looking for. They've read the problem, they've circled, they've written down, and now they have to find what in the world is the problem asking for. This is usually in the last sentence, but it may be somewhere else. I want them to underline the unknown and then write it down. So in this problem, here are all of my givens. The unknown is the time to the range. And so I actually have them write the word unknown and put T range. Now, If you have multiple equations, and in projectiles you are going to, this is the hardest thing for the student. They're going to want to pull the easiest equation and stuff numbers in that don't belong. What I recommend you do is, in many of the units where we have multiple equations, simply start with a list of all possible equations. Have them underline the givens in every equation, circle the unknown, and then pick the one that best suits that particular problem. For projectiles, these are the equations they're going to have to use, and this is quite frightening. It scares most teachers, actually. You have the x set of equations, you have the y set of equations. So let's step through our problem. We have the initial velocity, we have the angle, we have AY, we have the range. We're looking for T range. I have listed all of my projectile equations, and I usually will put these off on a sideboard and work this separately. Now, the first thing you want to do is underline all V naught Y. Now, I realize I've not gone through and computed V naught Y, and I would. V naught Y is V naught sine theta. Again, these are not usually problems we do with the A1 kids. But the first thing we're going to underline is all of the initial velocities in the y direction. The second thing we're going to underline is our second given, which is the acceleration in the y direction. So for every equation that has an AY, I'm going to underline it. The third given I have is delta y is 0. So everywhere I have a delta y, I'm going to underline it. I've gone through all of my givens, and now I'm down to my unknown. So when you go through and circle the unknown in every equation, you see there is one equation that has everything circled or underlined. It's certainly not this one. It's not this one. We don't know V final y with the givens we were working with. So we can't use this equation or this equation. The last equation, delta y is V naught yt plus some 1/2 ayt squared, has everything we need, either circled or underlined. So this is the equation they're going to need. And it certainly is not the equation they would have picked. I have done this with teachers, and the teachers always want to use this first equation, even though it doesn't have anything we really need in it. Now, unfortunately, you're going to have to grade the problems. That which is not graded is not done. Each problem that I grade is usually worth anywhere from 6 to 10 points. To grade, I give about 2 points for givens, 1 point for the unknown, 1 point for the equation, anywhere from 0 to 4 points for solving, and then 2 points for the solution. Let's step through these one at a time. For givens, I give 2 points. 1 point for listing everything, and 1 point for the units. If they do not include the units, they don't get that point. 1 point for the unknown, and it has to be in the form, the unknown is equal to question mark, question mark. This reminds them that that's what they're looking for. For the equation, I give them a point for each needed equation. It has to be the correct formula, and of course, in a multi-step problem, they may require more equations. Now, solving, anywhere from 0 to 4 points. If no solving is needed, then about 4 points, then 0 points, excuse me. Each step is 1 point. And then the equation must be solved for the unknown. Remember how I had them write u equals question mark, question mark? This is what they're solving for. So when we get down to the solve, if they've been looking for V naught up here, it must have V naught on the left side down here. And then the solution is 2 points. 1 point for putting the correct numbers into the equation, and then 1 point for the correct answer. You see, the answer isn't worth a whole lot, and as a matter of fact, they can totally miss this point and still do very well in my class.